Okay, hi everybody. We are going to go over all the notes I would like you to have for section 2.4. And you will find these notes not only in your student journal, but also in pages 92 to 94 in the book. And then I just put it this way so that you'd have less writing to do, and I can explain some things to you while we're at it. So make sure you have this either printed out or a separate sheet and you're ready to go. First, let's start by putting our name on it. I think you should always put your name on your paper and whatever period you're in. Now, the lesson objective is simply, it's very simple. It's students will be able to, if you've never seen the SWBOT before, that's what that stands for. We are going to write algebraic proofs and identify properties of equality and congruence. Because remember, when we're talking about numbers, they're equal, but shapes are congruent. Numbers, shape. Okay. So you actually already have had these before, so I'm not going to take up too much time going over it. But the addition property of equality says that if A equals B, and those are numbers, then A plus C is equal to B plus C. If you would like to abbreviate it a little bit, you can say that this is the add prop of equality. Because you'll see, sometimes it's just really annoying writing it over and over and over again. Same thing for the next one. If A equals B, then A minus C equals B minus C. So we can subtract the same thing from both sides. And then we have our prop of equality. You have to put the tr because we have substitution also, so you can't just put sub. The next one says if A equals B, then A times C equals B times C. You can multiply both sides. So this is the mult prop of equality. And you can divide both sides by the same side. So if A equals B, then A divided by C is equal to B divided by C. But here we have to say one thing. We have to say that C cannot be equal to 0. So that you don't divide by 0. If you've never seen that symbol before, it's an equal sign with a slash, meaning not equal instead of equal. And again, you can abbreviate this to div prop equals. We'll all know what that means. The substitution property I just love because it's so handy. Believe me, you'll use it all the time. And if A equals B, then A can be substituted for B. That's what it says. Or you can substitute B for A in any equation or expression. Now, we're going to abbreviate that as subst prop of equality. You don't have to write the word of, but there it is. And those are almost self-explanatory. You had them last year in algebra. Now, there's 3 more equalities we've talked about probably years ago, but they should all make sense to you. And these are the reflexive property. So we can write reflex prop equals. And what it means is every number is equal to itself. Every segment is equal to itself. Now remember, there's no segment sign because that would indicate the shape. This is indicating the length of the segment, just those 2 capitals. And then the measures, the measure of angle A is equal to the measure of angle A. That's what reflexive means. It is equal to itself. The next one, symmetric, is more like a mirror. meaning you can sort of swap them. So you can say sim prop equals, and if you have numbers, if A equals B, then B equals A. So you can swap them on either side. If you have segments and AB equals CD, then CD equals AB. And if you have angles, if the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A. Last, we have the transitive property. And the transitive property can be abbreviated trans prop equal. It means if you have two numbers, you have A equals B, and you also have B equals C, then transitive property says A equals C, because they're equal to the same thing. These are going to get right small on these. If AB equals CD and CD equals EF, then you guessed it, AB equals EF. And then last on the angles, if the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then measure of angle A equals measure of angle C. That is the transitive property. So now for this example, here's our first algebraic proof. Okay, we're going to solve this algebraic equation, and we're going to write every reason that we use from this list. So you're going to do two columns. Your first one is going to be your statement, or that's like where you put your work. And then over here, we're going to write the reasons. And the reasons are these algebraic properties. So the first statement is always simply writing the equation. And that we're going to call given. Somebody handed this to you. They gave you an equation. They said, solve it. It was given to you. So for the next step, you look at it and you think, okay, what do I want to do next? Well, I'm going to choose to undo this plus 2. So I'm going to subtract 2 from both sides of the equal. And that is the subtraction property of equality that says I can do that. And my next line now says 3x equals 21 minus 4x. So my next step, now that I have my numbers on one side, now I want to get my x's on the same side. So I could either take away 3x and make that one go away, or I can add 4x and make that one go away. I always like to add better. I like to do whatever will give me a positive. And I can see that if I'm adding 4x, that'll give me a positive. The addition property of equality, see, because I added the same thing to both sides, says I can do that. So the add prop equality says that I can do that. And now on this side, I have 7x. And over here, I have 21. So I still want to get x alone. I see that x is multiplied times 7. So I want to undo that multiplication, which means the opposite of multiplication is division. So I'm going to divide both sides by that multiplication. And we know that the reason is the multiplication property of equality. So that at the end, my answer is x equals 3. And because I am conscientious, I want to make my work look the best, I'm going to put a box around it. So now let's turn the paper over. If you didn't finish where I'm at now, just pause it and write till the end. I am going to expect you to get to this next part before we get to class tomorrow. So we're going to do 2 and 3 together under the doc cam when you get to class tomorrow. But for the meantime, I just wanted you to write down the distributive property. This is one more property that is in the book that we didn't put in the first part. It's on a different page. So what it looks like is this. Again, if you have these kinds of numbers and they're added, that's where the sum comes in, you can distribute the A onto the B and the C. And remember, that means multiplication. So this turns into A times B plus A times C. Simple as that. If you have the same thing with the difference, again, you can distribute the A over the B and the C, and you end up with AB, A times B, minus A times C. So that's how the distributive property of equality works. So hopefully you're ready for the next step to do these together. And yeah, great. Hopefully this recorded work.